So it seemed timely to put together a video here walking us through how to use a multimeter, or a lot of times what folks will say is a VOM. So lots of different names for this tool, trade names. I'll try to include as many trade names as I can, and nicknames. A lot of the things we use have multiple names or different names, but we're looking at a multimeter, a VOM, volt ohm meter. This one here in this photograph happens to be a manual ranging, and the reason we can see that it's manual ranging is there's a dial here, and notice along the scale here there's many different choices or selections one can make in order to provide the function or determine the measurement one wants to make with this type of meter. As you can see, it is AC-DC, so AC-V and DC-V. Sometimes we also are going to have a situation where rather than the AC or DC, they may give us some type of a symbol, and for AC, that symbol is always going to be the sine wave or the sinusoidal wave. And for DC, rather than a waveform, we're going to see a solid line, and then we're going to see a dashed line underneath it is the symbol for DC voltage. So again, this meter does both AC and DC. It's designed for voltage. This also measures DC current. However, this test lead right here is going to have to be relocated to this port right here. Now, for electricians working in the field, most of the time there isn't a lot of need for measuring DC current. Who measures some DC current? Oftentimes guys in the auto field. So auto mechanics working on cars are going to use a VOM to measure some resistance in a series circuit. And also, you know, on the electronic circuit board as well, and occasionally we find a need for that, but it's kind of an advanced situation, and most of the time hopefully you've had some experience in doing that, because keep in mind oftentimes you have to do it energized in order to get the correct reading. So I'm not going to go into much detail on measuring DC current, but it does exist, and we can use this meter to determine it. Resistance is something we're going to use often. We're going to look at the different resistors. Oftentimes in fire alarm systems and things, we need to install resistors to make them function properly. And the other very important feature is this continuity feature, and that is going to enable us to determine at any point in time if we have a complete circuit. And so what we would do is, if this were a length of wire, I would put my meter here in the middle, and I would put one test lead to one end, and I would put the other test lead to the other, and then what I would hear coming out of the meter is an audible beep or a buzzer or a bell or some type of audible sound, and that would tell me that I have continuity, that in fact my piece of wire is in good working condition. And then here at the bottom we have this black lead is always going to be in the common terminal here in the middle, and the red one, if it's in this location, is going to be used for voltage, resistance, milliamps in current, and then also this one has a temperature probe as well. And I'm not going to share with you how that temperature probe works, but oftentimes HVAC technicians are going to be using their VOM to measure different outputs for temperature. Here's a little more advanced meter. This one's going to move up a little bit in the price range. This one's made by Fluke. They tend to be the industry standard when you hear people talk about VOMs and choices, and good choices for VOMs. Certainly Fluke is always at the top of the list. And this meter, you can see, has some more simple features. There is this dial here, and the positions are a bit limited. We have some fewer choices. So we can have the meter turned off. Again, we can do voltage. Notice the AC sine wave I drew earlier. Voltage again. However, this is DC voltage with the solid line and the dashed line underneath it. This is a millivolt measurement. If we have to get quite small in measuring, we could use that setting. We have the omega symbol, which is for resistance. Here is the symbol when we're testing for continuity. That gives us that audible sound that we desire, so we can determine if that piece of wire or that circuit is intact. And this meter also does current, both AC current and DC current. In order to do AC current, you would actually get a different system. You could get a clamp, and I'll show you what a clamp-on meter looks like here in just a second. But this is not typically something you're going to use with a VOM, and again, you may do a series current reading in a DC circuit, and so that might be common. We talked about that earlier, both in the automotive and also electronic situation. A few more test probe points down here where they can plug in. This side is kind of on the current side, so not real common. And over here we're going to have our red one. Notice again it says voltage, it says omega symbol, and there's also a symbol for a diode there to check those. And then the black one goes simply into the common port on the meter. So this is a multimeter, again, VOM, volt ohm meter. Does voltage, does DC current. Notice the big feature on this one's auto ranging. So now we don't have any scales that we have to adjust to. We just simply turn it to the desired voltage, continuity, or the current that we're measuring, and it does all of the thinking for us. Here are our AC clamp-on meters, and this is what we're going to use to determine and to measure the current flow in a circuit. So we're going to use something called an ammeter, and this clamp feature is really nice. We just simply take our thumb, we push down this button, this clamp opens, and our conductor is going to tuck right inside that clamp. And how this meter works is it senses and it measures the amount of magnetic field that is going to bleed off of that conductor when we're running AC current through it. And inside of this is a current transformer that's capable of measuring that magnetic field. We've got some circuit board capabilities inside the meter. It measures that magnetic field, it automatically does some calculations, and it displays to us on the screen the amount of current that we are drawing on that circuit. I've got two varieties here. Again, we've got on this side, we've got the manual ranging, so it does volts, ohms, and amps. Right now, the way this one's set up, it's set up to measure current in amps. The reason being is I don't have the test leads installed over here on this one. So this one, the test lead ports are open, so therefore we're going to go ahead and we're going to measure amperage or current. This one has a hold feature. That hold feature is really nice when you're in a cramped location and you're standing on your head and you've got your meter in there and you've got your current reading made, but you can't see the meter well enough. You go ahead, you hit that hold button, and it will hold whatever it measures on the digital display for a time, so you can view that in an easier location. Again, this one has the dial range, and so you're going to have to adjust to the particular scale. Typically when you're using a manual ranging meter, you always start at the highest scale and then you begin to work your way down until you find your lowest current value, and you measure it, and that way you can make sure you have the most accurate measurement that you can make. Over on this side, we've got an auto ranging. So again, this one does all of the thinking for us. In this case, if we have these test leads in this location, we can also use these to determine some voltage. It has a continuity feature There's also a resistance feature on this one, and we'd use those test leads to do that. So this one's auto ranging, does volts, ohms, amps. This one also has a non-contact feature, and so if you had this meter in your hand, you didn't have your test leads in place at that moment, you could go ahead and hold the tip of this meter near a voltage source, and then you go ahead and you push this NCV button, and that will give you a audible sound. It sounds like a cricket chirping. In a non-contact voltage meter, you just simply hold this section next to the conductor. Again, it senses that magnetic field, and it gives you an audible signal telling you that that circuit is in fact energized. There must be care taken when doing current readings, because remember, in order to measure current, we have to have electron flow. In order to have electron flow, the circuit needs to be energized. So we always need to be careful when using the meter to measure current. Here's a nice shot of the AC clamp-on meter in use. Notice here's my blue conductor. I've inserted and I've clamped that conductor around, or the clamp-on meter around the conductor. Again, we can't see it, but we've got that magnetic field that is surrounding that conductor. It's being picked up by that meter. We've used our ranging feature here. In this case, I've got the dial turned to the 20A, so this right now is capable of measuring 20 amps if we needed to go that far. And if we got to the point where maybe we were under 5 amps, maybe then we would want to go ahead and readjust and get down to the 2 amp range. And if it kept going down, we'd have a little more accurate measurement then using that meter. Just another shot of the conductor inserted into the AC clamp meter, and just kind of wanted to re-emphasize this hold button. So if we go ahead and we push that hold button down there, that's going to allow us the flexibility of being able to see our current value show up in our screen at an easier location where maybe it's dark or we're inside of some cabinet and we're not able to see it very well. So that hold button does give us a nice ability to make sure we can determine a good, accurate reading.